Let's consider the following table of values for x and y. I've got x starting at -1, 0, 1, 2, 3, 4, 5. And the y's are 4.037037, 4.111111, 4.333333, and so on. And then I start with whole numbers. I've got here 5, 7, 13, 31. If we work out the first differences between the y's, over here, between y1, y2, and y3, and y4 even, I've got decimal numbers, which you can see over here. And then I start having first differences, whole numbers, 2, 6, 18. The second differences are the same multiples of 3, they go up in 3, but they are of no relevance for now. As we can see, the first differences multiply by 3, so that tells us the first difference are multiples of 3. This tells us that we are dealing with an exponential equation with base 3. Now let us plot the points from the table. And we take the first point, which is -1 and 4.0337, and that's the one here. Then the next one is 0 and 4.111111, 1 and 4.3333, 2 and 5, 3 and 7, 4 and 13, 5 and 31. So we know already that this is an exponential equation because of the first differences being multiples of 3. And now having those plots, I can actually connect them, and it looks like this. As we can see, the y values are approaching, the further we go down the x scale, the y values are approaching 4. So the further we go down, the more they approach 4. That tells us that y equals 4 is the asymptote of the graph, and that is this dotted line here. Now, the first point where the graph is 1 up from 4 is when y equals 5 and x for that value is 2. So that tells us that the graph is actually shifted up by 4 and by 2 units to the right. And now we can write the following equation: 3 to the power of x minus 2 plus 4. And that's my equation. Yes, and now if we try those numbers here, we'll get the respective y's to correspond to those x values. And that's how we work an exponential of the graph from graph to equation. Thank you very much for watching.